Hello everyone. We'll solve now question number 2 of correlation. Here it is given find the correlation coefficient between the size and the proportion defectives from the following data. Size is given in the form of a class interval. Then production quantity, how much is produced, that is given. Defectives out of those produced quantity is also given. How do we solve it? Since the data is given in the form of a class interval, we need to take the middle value. In the sense, 15 and 16, the middle value is 15.5. Likewise, 19 and 20, middle value is 19.5. 20 and 21, middle value is 20.5. So those things we have to consider as our variable x, 15.5, 16.5, up to 20.5. Then we need to find the correlation coefficient between the size and the proportion defectives. So that means we need to find out the proportion defectives in terms of percentage. So defectives divided by produced into 100 means 140 divided by 200 into 100. First one will become 140 divided by 200 into 100, 162 divided by 270 into 100, like that. So we have to find out proportion defective and write those proportions. Now we have to find out the correlation between x and y. So we can think about simplifying this data by using the third property, whatever we had seen in correlation coefficients. Third property means numbers can be simplified by bringing in an origin and bringing in a scale. So if you look into this, I can bring something middle number as the origin. So middle number exactly it will not be there because the number of observations are even number of observations. So either I will choose 17.5 or 18.5 as origin. I will choose 17.5. Similarly, here I will choose 50 as the origin. So if I do that, 15.5 minus 17.5, that itself is giving me a smaller number. So nothing to be divided. So I'll simply, just for showing purpose, I will divide it by 1. Here, everything, if I subtract it by 50, I will get some number which is divisible by 10. So I will divide it by 10. That means here my origin will be 50, my scale will be 10. That's what is written here. In order to simplify the numbers in the data, we will use one of the property of correlation coefficient as below. Means we are bringing in a new variable u, which is x minus 17.5 by 1. Here the origin is considered to be 17.5, scale is considered to be 1. Similarly for u, origin is considered to be 50 and scale is considered to be 10. Now we can find the correlation between u and v instead of r and x, and then subsequently we can find the correlation between x and y. So revised data will become, so you substitute all this, means x minus 17.5, what is x? It is 15.5 minus 17.5 divided by 1. 15.5 minus 17.5 is negative 2. That's why I wrote here negative 2. Likewise, you do it for all these values. Similarly, v is what? Y minus 50 by 10 means 70 minus 50, which is 20. 20 by 10 is 2. Similarly, 60 minus 50 is 10. 10 by 10 is 1. So we'll have 2, 1 like that, right? So now you need u square, you need v square, you need uv. So we do all those things, then take the sum of all these things, because all these sums are required, I mean totals are required to be substituted in the formula. Here it is, right? So we substitute all those formulas and arrive at this value. Now the property says that we can find out r xy by substituting this formula. In our case, what is b? b is the scale of x, which is 1, and d is 10. So 1 and 10. So modulus of 1, modulus of 10 into negative 0.983 divided by 1 into 10. So this modulus of 1, modulus of 10 is also 1 and 10 only. So I can straight away cancel this. So even r xy will be the same as r uv. So that's this particular solution for this particular problem. So we'll see again in our next video. Till then, see you all. In case if you find this video to be useful, I request you to please like, share it to your friends, and subscribe to my channel. Thank you.